Hello chemists, let's talk some ions. Now in a previous video I spent some time talking about atomic symbols, and we're going to expand on that and deal with ions where we have charged particles because the number of protons and electrons do not match up. So that's the condition to form an ion. This will be a charged particle. And again, when I say charged, I'm saying it's electrostatically charged, meaning it could be carrying a positive charge or it could be carrying a negative charge. Now, we're going to be dealing with atomic ions, so ions that are formed just from atoms. But later we'll be dealing with more complex ions where we got multiple atoms, most likely from different elements that are chemically bonded together that carry a charge, an electrostatic charge. So cations are positively charged ions, and anions are negatively charged ions. Now, cations are going to be formed when the number of electrons is less than the number of protons. Remember, protons carry a positive electrostatic charge. Electrons carry a negative electrostatic charge. When those two are equal, the number of protons and the number of electrons, the electrostatic charge overall cancels, so the atom in this case would be electrostatically neutral. However, if you start losing some electrons, that case I'm going to have more positive charge than negative charge, so I'm going to have these positively charged cations. And anions would be the opposite, where the number of electrons is now greater than the number of protons, so there's more negative charge on that particle than there is positive charge. Give you an example. So let's say we have an ion with a charge of 2+. So what does this tell you about the number of protons and the electrons? First of all, I want to point out the way that I'm writing the charge as 2+. I'm not going to write it as +2. Later it will introduce something called an oxidation number. And oxidation numbers are often written with the plus in front of the number. So when I write 2+, I'm trying to distinguish this from an oxidation number. Sometimes the oxidation number and charges are the exact same thing. But here I'm talking about electrostatic charge. So I'm going to write the number followed by a plus. So this would be a cation, positively charged. So what does this tell us about the number of protons and electrons? Well, a proton carries 1 unit of positive charge. An electron carries 1 unit of negative charge. Because I've got 2 units of positive charge residing on that ion, well, I must have 2 more protons than I do electrons in this ion. And again, this ion would be a cation because it's positively charged. So let's take some ion symbols. Now, if you've seen the previous video on atomic symbols, these are pretty much atomic symbols. The only difference now is that I've got the charge of the ion listed in the upper right-hand corner. So first of all, lock into those elemental symbols. For instance, lithium and sodium, magnesium, aluminum, carbon, oxygen, and fluorine. Right? We can get those directly from the periodic table. And from that periodic table, then we can get significantly more information, such as, well, in this case, I guess we'd have to be given the mass number in the ion symbol, right? The mass number is the sum of the number of protons and neutrons at the nucleus. So this would have a total sum of protons and neutrons at the nucleus for lithium as 7. Sodium, this would be the sodium-23 isotope, magnesium-24, and so on. There we've got that charge. I've already pointed that out. Notice some of these are anions. We've got 3 anions down here because they got negative charges. All these first 4 are all cations because they're positively charged. And here's where we have that number of protons, the atomic number that we can get from our periodic table. So if I read across here, lithium has 3 protons at the nucleus, sodium has 11 protons, and so on, all the way down to fluorine, which has 9 protons at the nucleus. Now with that charge here, because I know the number of protons at the nucleus, and knowing this charge here, I can tell you how many electrons are in an atom of lithium-7 if it's a +1 charge. So if it's a +1 charge, that means I got more protons than I do electrons. And for every positive unit here that I have up here, I've got 1 more proton than electrons. So since this is has a single, because it just says plus, I can interpret this as 1+. Same for sodium, 1+. So if I've got a positive charge, a single unit of positive charge on this lithium atom here, well, that would tell me I have one more proton than I do electrons, leaving me with 2 electrons in this ion. Same thing for sodium. I've got one more proton than I do electrons to give me that 1 plus charge on the sodium 23 ion. For magnesium, notice it's 2 plus. That would indicate that I've got 2 more protons than I do electrons. For aluminum, well, in this case, I've got 3 more protons than I do electrons. Now for carbon here, now we've got an anion. In this case, because I've got a negative charge, in this case 4 units of negative charge, I must have 4 more electrons than I do protons. So in this case, I'd expect to have 10 electrons for this particular anion. Oxygen, I've got 2 more electrons than I do protons because I got 2 units of negative charge. So I have 10 electrons. And this last one, because it's just, again, this is just a minus, you can interpret this as 1 minus, so a single unit of negative charge on this fluorine atom, I would have 10 electrons, 1 more electron than I do protons. Remember, if I had 9 protons and 9 electrons, this would be electrostatically neutral and it would not carry any charge. Now in this particular example, I did formulate this so that I thought it would be kind of neat to see what would happen. These are very common ions that form for these different elements, and matter of fact, they all have the same number of electrons. Why would that be? Well, we'll discuss that in a later video. All right. Well, if we want the number of neutrons, well, we've got remember the mass number is the sum of protons and neutrons at the nucleus. We've got the atomic number, which is the number of protons at the nucleus. So 7 minus 3 is going to give me the number of neutrons at the nucleus, and that would be 4. And you can go through here and verify these for yourself. So for instance, aluminum with a mass number of 27 minus the 13 protons means I've got 14 neutrons at the nucleus. So let's take another example. Let's see if we can write the ion symbol. So let's go backwards. Here I gave you, in the previous example, I gave you the ion symbols, and then I asked you to piece together, I guess we worked together to piece together the number of protons, electrons, and neutrons. Let's go backwards here. Let's say we've got an element now that's got a 6 plus charge, meaning this is a cation. It's got 18 electrons and 28 neutrons. Let's see if we can write the ion symbol. Well, if I'm going to write the ion symbol, first of all, I better know what element that we're talking about. So I got to start there. Now, this is a 6 plus charge, and you're telling me, well, you're not telling me, but the problem's telling me I've got 18 electrons. Well, if this is a cation, that must mean I have 6 more protons than I do electrons. So my number of protons is actually 24. So here I write it out here. So 6 plus charge means there are 6 more protons than electrons, because the protons carry positive charge, electrons carry negative charge. So there must be 24 protons. Go to my periodic table. I can find the element with an atomic number of 24. That's chromium. So that's where I start with my ion symbol. Now I still have to figure out what's the mass number and what the charge is going to be. Now remember, down in this lower left hand corner is where you sometimes write the atomic number. Again, I'm going to say that that's redundant, because if I'm working with chromium, I can go to the periodic table and say, oh yeah, that has an atomic number of 24. Well, I don't even have to think too hard about this. If I want to write down the charge is given to me in the problem. It's 6 plus. All right. And then finally, if I want the mass number, which is going to go right here, that's the sum of protons and neutrons. Well, I just said I got 24 protons. The problem's telling me I got 28 neutrons. If I add those two together, I'll get a mass number of 52. So I hope you found this video useful. Thanks for watching.